Here's a rather quick lecture about free-falling objects. We're going to look at Newton's laws. Well, just one of them really. Where you either drop an object or you throw it straight up into the air or you throw it straight down into the ground. There are ways of determining how fast the object is going at any time and some other stuff. So let's take a look at free-falling objects. If an object is thrown upward, well, I'll just say thrown up / downward with an initial velocity of v sub 0. So if an object is thrown up / down with an initial velocity of v sub 0 at a height s0, the height, let's call it position, the position at any time t is s of t equals -1/2 g t squared plus v0 t plus s sub 0. G is the gravitational constant of where we were at. And I've pulled a problem out of our current textbook, and we'll use this formula for it. You can see a stone thrown vertically on Mars. Suppose a stone is thrown vertically upward from the edge of a cliff on Mars, where the acceleration due to gravity is about 12 feet per second squared, with an initial velocity of 64 feet per second from a height of 192 feet above the ground. The height of the stone above the ground after t seconds is given by, so let me show you, 12 feet per second squared is Martian gravity. And I said you need to put the initial coefficient as -1/2 g. So -1/2 of 12 is -6. It was thrown with an initial velocity of 64 feet per second. 64 here. Now if it were thrown downward with that, this plus would be a minus right there. So that corresponds to the v sub 0 in the formula. Finally, 192 feet was the initial height. So let's go ahead and solve the questions they're asking us for. So they want us, first of all, to get a formula for the velocity. So part A. Always remember v of t equals s prime of t. Velocity is the first derivative of position. So if I take the derivative of s, don't remember how we do this, using the power rule, that 2 on the t squared comes down and multiplies to the -6. So I get -12t. Next, the derivative of 64t is just 64 because the derivative of t is 1. And finally, the 192 simply disappears because the derivative of 192 is 0. So this is a formula for my velocity right there. When does the stone reach its highest point? Well, the answer to that is when v of t equals 0. If it reaches its highest point, it's neither going up nor down, so its velocity is 0. So when does that happen? Well, v of t I just had there, so I have to set negative 12t plus 64 equal to 0. Solving for t, I'll have negative 12t equals negative 64. T equals 64 over 12. I'll do the simplifying in my mind. That's okay. 32 over 6, 16 over 3. Probably could have divided by 4. So that is 5, and let's put decimals. 5.3 bar seconds. What is the height of the stone at its highest point? So part C, well, the height or the position, I need to plug in. I guess I don't know that I want to use that thing because I'm going to be squaring it and things like that. I'm going to say 5. It was also 5 1/3, or it was 16 over 3. This is going to be the most desirable thing to plug into here. 16 over 3 equals negative 6 times 16 over 3 squared. I'm refusing to use the calculator in case you're wondering why I'm not going that way. You can, of course, use your calculator for all these things if you want. Plus, what was the initial velocity there? 64. 64 times 16 over 3 plus 192. So this tells us how high the object actually went, because S measures things in terms of feet. So I have negative 6 times 256 over 9 plus 256 and 1024 over 3 plus 192. I can do some simplifying, I guess. Let's take this out, take this, and I will put a 2 there and a 3 here. So that's negative 512 and 512 over 3 plus 1024 over 3. Well, this isn't the worst thing in the world. Plus, I got to write that thing over 3. So 600 minus 24 is 576. 576 over 3. And that equals 512 plus 576 over 3. That is 1088. 1088 over 3. So whatever that is, if you want to do that, just fun. Remember this stuff? 3 goes into 10 3 times. I put a 9 here. 1, 8. 3 goes in that 6 times. 8. Then I have an 8 that I brought down. 3 goes into that how many times? 2. And then I have 0.6 with the bar over it. So that equals 362.6 with the bar over it. Feet. Now, I am going to check this. First of all, I'm okay with this answer here. We're going to go to, well, your calculator. It's under my Way Of It menu. Bring it up. Okay, let me first make sure I did the first computation correct. 64 divided by 12. Good, that's good. Then let's see what happens when I plug it in there. I'm going to use this 5 point. I don't know if I'm going to do that. Hey, this isn't a bad idea. Try this. Go store and then do alpha T. Capital T, not the script T that's on that board, on that certain button there. So I'm going to do then negative 6 alpha T squared plus 64 times alpha t plus 192. 362.6, and I think that's what I got, yes? So if you had to have a decimal, there you go. What other questions do we have here? D, when does the stone strike the ground? Well, that's when the height is equal to 0. So I want S of t to equal 0. S of t was negative 6t squared plus 64t plus 192 equals 0. What I'll do, I think, well, 3 doesn't go into everything. 2, the only number that goes into everything here is 2. So actually, I'm going to divide by negative 2. And I'll end up with 3t squared minus 32t minus 96 equals 0. Use the quadratic formula. T equals negative b, so this part here is the b. Negative of that is 32 plus and minus the square root negative 32 squared minus 4. The a is equal to 3 and the c is equal to negative 96. The whole thing, I'm going to stop for a second here. I've seen this too many times and it just drives me up a wall. You see if you're guilty of anything like this. Some students will draw an insufficient vinculum or an insufficient division bar, and they'll dutifully write 2 times a in the denominator like they're supposed to, but for some reason they don't. I'm not sure they know that this 32 is also part of the numerator. Some people I've even seen write something as silly as this, like they'll put the 32 here or something, and then it totally loses any possible meaning anymore when that happens. So let me take it out. I'll put my 32 back up here, and I will increase this division bar to include the 32 with it. Now, I am a little bit tired of calculating things in my brain, so I'll let the calculator do some of this for me. This equals 32 plus and minus. I do encourage you, though, to exercise those dormant neurons that are meant to multiply and divide and all that kind of stuff. Let's see, I have 32 squared. Notice I didn't put the negative. I don't need to worry about it because when I square it, the negative will go away. Similarly, you see this negative here and this negative here will all go away. So I'm going to have plus 12 times 96. Enter. I think it looks to me like 4 goes into everything, maybe even more. Let me divide by 4, everything by 4. Oh, I bet 4 goes in that too. Divide by 4. This 4 goes into that also. This is the third 4 I'm doing. So 64 went into all that. I'll show you what I mean. I had 32 squared plus 12 times 96. And 64 went into that number. At 34. So this is 32 plus and minus the square root of 2176. All of that is over 6. Now, as I just mentioned, 64 goes into that number. 64 times 34. All over 6. And this equals 32 plus and minus 8. Radical 34 over 6. Now, you have 2 answers here. Let me write them out. I have 32 plus 8 radical 34 over 6. Oh, by the way, this is seconds. Remember, this is how long it was taking for it to hit the ground. And then on the other hand, I have 32 minus 8 radical 34 all over 6. Without going to the calculator, you should be able to reason that this number here is to be gotten rid of because it is negative. And that makes no sense in the context of this problem. This problem started when time equaled 0, and we started from that and counted seconds after 0. So the only one that makes sense here is the positive one. And I can simplify a little bit here. This is where, if your division bar isn't long enough, you might just divide 2 between the 6 and the 8 and forget to do it to the 32. No. You must think of this whole numerator right here. You must think of this as 2 times 16 plus 4 radical 34 all over 2 times 3. That way I can cancel the 2's. So my final answer is 16 plus 4 radical 34 over 3. And I'll go ahead and get a decimal for that thing now. It's not too hard to do on the calculator as long as you're okay with your parentheses. Let me put my parenthesis. 16 plus 4 square root 34. Finish the No. Do you see what happened there? Got to get that out of there. I got to go back and delete that. You've got to escape the vinculum that is the top portion of the square root. I have to get out of there. See that? You see how it changed? Now my parenthesis is on the outside of it. So it'll grow with whatever you're typing if you don't move outside of that field. So I'll divide by 3 and give me, so about 13.108 seconds. So approximately 13.108 seconds. And I believe there was one last question here, and it was, with what velocity does the stone strike the ground? So as it's hitting the ground, it's going some speed. How fast was that? Well, you can completely estimate, use this as the time, and simply plug this into the velocity. So I can do v of, I'm going to put this number in because I'm going to show you it's not that bad. 16 plus 4 radical 34 over 3. That is the velocity at any time. So when I plug it in, I end up with negative 6. What was it? Negative 12 times 16 plus 4 radical 34 over 3 plus 64. The reason why I said it wasn't that bad is because when I do this, the 3 cancels with the 12. I'll make that a 4. And when I multiply the negative 4 through, I get negative 64 minus 16 radical 34 plus 64. The negative and positive 64's cancel, and we are going negative 16 radical 34 feet per second the moment they hit the ground. Important question here is, why is that a negative number? Negative because it's going downward. Because the object is falling. So, if you want to go ahead and get a decimal version of it, that's fine with me. There are some questions that were not asked. What is the acceleration of the object? Well, the acceleration, a of t, is actually equal to the derivative of v. Acceleration is the derivative of velocity. And the velocity, if you remember, v of t was negative 12t plus 64. If I take the derivative of that, with my cursor, I'll end up with negative 12, and you'll put feet per second squared for that. Notice it's constant. There is a constant pull of negative 12 feet per second squared in the downward position, since you're being pulled towards the surface of Mars in this case. So that's the only of all the word type problems in this around here. We'll do other word problems, but when it comes to instantaneous velocity, they're all going to look just like this problem. So until next time.